day everyone, welcome to ICT Online Learning. For this day, let us proceed to the next chapter that is about chemical names and formulas. So for that, we have from atoms to compound. Just like atoms, molecules are electrically neutral, that is they have equal number of protons and electrons. When an atom or a molecule acquires a net charge, it becomes an ion. An ion is an atom or a group of atoms having a positive or negative charge. A positive ion results from the loss of one more electrons. On the other hand, a negative ion results from the gain of one or more electrons. Now, example of ions are the chloride ions or Cl negative and sodium ions that is Na positive. A positive ion is called a cation, while a negative ion is called an anion. Ions can also be a polyatomic. Now, let us proceed to the chemical formulas. The first one is the molecular formula, which it gives the exact number of element or each element present in the smallest unit of a substance. A formula showing the types and numbers of atoms combined in a single molecule of a molecular compound. It is a whole number multiple of the empirical formula. Now, for us to understand, so we have here the relationship between a compound's empirical and molecular formula can be written as follows. So we have X multiplied by empirical formula equals molecular formula. Also, X is multiplied by empirical formula mass is equal to the molecular formula mass. So meaning, this particular X that is the number wherein you can get the ratio. Example, in the first formula, so we can solve X by X equals molecular formula divided by empirical formula. In the other formula, so we can solve X by dividing molecular formula mass divided by empirical formula mass. Now, for the steps, number 1, to determine the molecular formula of a compound, you must know the compound's molar mass. Second, divide the molecular mass by the empirical formula mass to determine the whole number multiple X. And then you may have to find the empirical formula in order to obtain the empirical formula mass. Okay, so that is the steps how to solve the compound molar mass. At the same time, there is also a steps how to solve the molecular formula. Now, for that, so let us try some example to how to solve this particular problem. So let us solve this example. The empirical formula of a compound of phosphorus and oxygen was found to be P2O5. Experimentation shows that the molar mass of this compound is 283.89 gram per mole. What is the compound's molecular formula? Now, in this problem, first of all, we need to identify the given. For this, so we have the given for the empirical formula, that is P2O5, and we have the molar mass, so that is 283.89. Now, what is the next step? So the next step, we need to determine what is the empirical formula mass. By using this solution, to solve the empirical formula mass or the empirical mass, you need to find first the atomic mass of phosphorus and oxygen. And then after finding the atomic mass of phosphorus and oxygen, so you can now solve the empirical mass. Probably the atomic mass found in the periodic table for us to easily solve this particular empirical mass. Now, if you identified the atomic mass of phosphorus and oxygen, so just simply follow these steps. So just simply, you need to multiply the atomic mass by 2. Since the empirical formula is P2O5. And then the atomic mass of oxygen, you need to multiply it by 5. Then after that, then get the sum of that two product. So you will come up with 142 gram. So that is the empirical mass of this particular compound, which is phosphorus and oxygen. Then after finding the empirical mass, so you can now solve the ratio between the molar mass and empirical mass by using this step. So just simply use the molar mass 283.89 gram divided by 142 gram. Just simply solve it to get the ratio of that particular value. Then after getting the ratio, that's the time you can now solve the molecular formula by multiplying the result ratio to the empirical formula. So it will become 2 times P2O5. So the answer for the compound's molecular formula is P4O10. Okay, so that is the answer for this problem. Okay, now another, so we have the empirical formula. Empirical formula are formulas that show which elements are present and in what ratio they exist in the substance. The main difference between molecular formula and empirical formula is that in empirical formula, the ratio is at its smallest whole. And the number value, while a molecular formula shows that the actual number of each element in the substance. Okay, so that is the difference between the empirical formula and the molecular formula. Now, for us to understand how to solve by means of empirical formula, so let us try this example. Okay, for this example, so the percent composition of compound was found to be 63.5% silver, 82 or 8.2% nitrogen, and 28.3% oxygen. So let us determine the compound's empirical formula. Now, for us to determine the compound's empirical formula, first, the given elements, which is silver, nitrogen, and oxygen, so we need to divide their composition or percentage composition for their respective atomic mass. So that's why if you take a look the solution, so we have the silver, 63.5 gram, that is the percent composition, then divided by 108 gram, that is the atomic mass of the silver. So you will come up with 0.588. Also in nitrogen, so the percent composition is 8.2 gram divided by 14 grams. So the answer is 0.585. And then for oxygen, so we have 28.3 gram divided by its atomic mass, that is 16. Then the answer is 1.769. Now, after determining the ratio of the percent composition and then the atomic mass of that element, so the next step is you need to take a look what is the smallest value of that three elements. And then after determining the smallest value of those three elements, the next step is you need to divide all of them by the smallest value. So that's why if you take a look, the smallest value is 0.585. So that's why you need to divide those numbers into the smallest value, which is 0.585. That's why in silver, if you take a look, so we have 0.588, then divided by 0.585. So the answer is 1. For the nitrogen, so obviously that is the smallest one. So that's why if you divide the number, so the answer is 1. And then for the oxygen, so we have 1.769 divided by the smallest one, that is 0.585. So the answer is 3. Now, after getting the value by using the smallest quotient of every element, the next step is just simply take note, divide all by the smallest one for us to give the empirical formula. Now, for that, so since we already identified the value, so now we can write the empirical formula. Since the elements are silver, nitrogen, and oxygen, so by using those values, so we can now write the final answer for the empirical formula. So for the silver, so we have Ag. For the nitrogen, so we have N. And then for oxygen, so we have O. But take a look for the oxygen, so we have the 3 value. That's why if you take a look the answer, so we have AgNO3. Okay, so that is the value for the oxygen. So meaning the answer for this problem is AgNO3. That is the compound's empirical formula for this problem. Okay? So that is the final answer. Okay, so I think that's all for this day. So thank you so much and have a good day to everyone.
For more ICCT College's video updates, please subscribe and click the notification button.